Alright, welcome to another day. This is going to be our last bit about similar triangles, and in today's lesson we're actually finally applying these things to some real life scenarios. So what's going on in this first one is the student's using a mirror to figure out the height of a statue. So evidently the student laid out a mirror 4 meters from the base of a statue at an unknown height. That's what we're looking for. Now, from that mirror, the student would walk away until the student could see the top of the statue in the reflection of the mirror. And that student had to walk away 2.4 meters before that would happen, and the student was evidently 1.8 meters according to the diagram. So in this first problem, really a lot of information was given in the diagram. In the second problem, we're actually going to see where we have to make the sketch more ourselves, but I'm giving you a walkthrough of where this diagram did come from. Now, due to the reflection, these two angles right here would have to be the same. This is my unknown value that I'm looking for, which is that representing the height of the statue. Now what I can do is actually make a proportion and solve it. So what I'm going to do is say that x, the height of the statue, would correspond to the height of the student, 1.8 meters. So x over 1.8. And that would equal the distance away from the mirror over the distance away from the mirror. So the 4 meters over 2.4 meters. And now I've got a proportion to solve. I can multiply the 2.4 meters with the x, so 2.4 times x equals, I can multiply the 4 with the 1.8, and that would mean that 2.4x would equal 7.2 when you multiply 4 and 1.8. And then I'll divide by 2.4 and get x equal to 3. Sorry, I ran off the screen there. So 3 meters is my final answer for the height of the statue, which proportionally 3 to 4, 1.8 to 2.4 seems pretty in line. Alright, on this next problem, different situation, we're actually going to be using a common tool, which is a shadow. Alright, Peter Pan, let's go. So what's going to happen is a 40-foot tall flagpole is casting a shadow that's 25 foot long. Now we are going to assume that this is a right angle. All right. Now what would happen is at the exact same time, we're going to figure out how long the shadow that's cast by a 200-foot tall building. So I am given the height in this case. Now I know that this is not to scale because it would be much larger than this compared to the 40 feet. But a 200-foot tall building is going to cast a shadow, and we're trying to find the length of that shadow without necessarily having to measure it. Let's go ahead and set up our proportion. Now you would do height to height, so 40 over 200 equals length of the shadow to length of the shadow, 25 over x. Just make sure that you're always going in the same direction with your ratios. Now what I can do is cross multiply. Some people like to actually get kind of fancy and simplify this down a little bit. So if that's you and you want to say, you know what, 40 divided by 200 can simplify to 1/5. I dig it. All right, so now let's cross multiply. So 1 will multiply x, so that's 1x equals 5 will multiply 25. And so 1x, I actually can just change to being x equals 5 times 25. Well, that is going to be 125-foot long shadow. So 125 feet is my final answer for my shadow. All right, this is going to be my last problem that I'm going to go over. Basically, the whole concept here is that perimeters are going to follow the same proportion or same ratio as the side lengths. So what's going to happen? The length of sides of IJK, triangle IJK, are 40, 50, and 24. Just going to make a quick sketch of that. 40, 50, 24. I know that that was not at all to scale, but that doesn't really matter. So this is triangle IJK. Our ultimate goal is to try to find the perimeter of triangle TUV. Now, what they do here is they do give us the longest side of TUV. So the longest side of TUV is 275 units long. What that does is actually allow me to make a ratio that the parameters would then follow. Now, you might be like, well, they didn't give us a parameter. Well, they gave us enough information to figure it out. So what I'm going to do really quick is add 40 plus 24 plus 50, and I'm going to get 114 for the perimeter of triangle IJK. Now, what's going to happen is I'm actually going to be able to make my proportion here. So one of the ratios I can make is 50 to 275. The reason why I can make that is because in the problem they said the two triangles were similar, and since 50 is the longest side on this triangle, and they said 275 is the longest side on this triangle, they have to correspond. Now I'm going to set that equal to the ratio of my parameters, which are going to follow the same ratio. So since 114 is the perimeter of the smaller triangle, that's going to match up with the 50 here. The unknown parameter for this larger triangle is what I could put in as an x. Now that I've got it set up, I can use cross multiplication to finish up this problem. All right, so I'll go ahead and finish that. 50 multiplies x. 275 multiplies 114. Totally just going to use a calculator off to the side here. 275 times 114 ends up being 31,350. Then I can just divide that answer by the 50. I'm going to do that. Divide by 50 is 627 units. They didn't ever tell us what units we were actually using here. So my final answer, the perimeter of the larger triangle, is 627. All right, folks, good luck on your assignment. If you got questions, you're just not getting a setup, please email me. I will try to promptly email you back to try to give you a little bit of help on some of these. They can be a little bit tricky to think through, so please let me know if you need some help. I appreciate y'all. Bye.